All right, today what we're going to be talking about is how to prove that two right triangles are congruent to each other. Up to this point, we've been mostly working with triangles that are isosceles or equilateral or equiangular, scaling, those type of triangles, but we haven't dove into the world of a right triangle. So today that's what we're going to be doing. So first of all, we're just going to discuss the parts of a right triangle. This should be a review for you. All right, so the legs of a right triangle are the sides adjacent to the right angle. A hypotenuse is the side opposite the right angle. So for example, in my lovely picture, I have a leg, which is adjacent to my right angle, and exactly opposite of that is my hypotenuse. All right, so with that, we will dive right into our theorem for the day. We have a hypotenuse leg congruence theorem. This theorem states if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So basically what that is saying is if I find that AC is congruent to DF, and I find that my hypotenuse AB is congruent to DE, there is no reason, and I know that these are right angles, there's no reason I need to find that CB is congruent to FE. I can simply state that these two triangles are congruent by the HL or hypotenuse leg theorem. Okay? Just like the SSS or the SAS, you can use this acronym HL and everyone will know what you're talking about. Okay? So for this lesson, instead of having my normal proofs on my smartboard lesson, what I'm going to do is I actually have this great website. It's called the Math Warehouse. It's got wonderful proofs actually on here. So the first thing is you can go through and we can actually look at some of these different triangles. So it's just re-explaining what the hypotenuse leg theorem states. But then further down, what it will actually do is um, help bring you through a proof of this. So we have that CA is congruent to AB. So I can actually say that right away. It's given. Okay. Then I can say that ADC and a certain other angle, which in this case is ADB, are right triangles. I believe the second given up here that is being corrupted by the website for whatever reason states that CB is perpendicular to AD. Okay, and with that, we can find that perpendicular lines create 90-degree angles. You could also just say that perpendicular lines create right angles, or you could say definition of perpendicular lines, however you want to state it. Okay? So with that, we have that these are right triangles. So far we have the hypotenuse, the right triangles. Now we need to figure out a leg. Well, I know that AD is congruent to AD because of the reflexive property, so that would be my leg. So I can figure out that ADC and ADB are congruent because of the hypotenuse leg theorem. All right. Um, Here's another proof. This one's not as corrupt, or this one's not corrupted. So, um, same sort of thing. You can go through, click next. It shows you the reasons. It's a really, really, really great a really great resource. It's called the Math Warehouse again. If you want to visit it and do some practice, I would highly recommend that. All right. And I would also highly recommend maybe filling in the reasons for this particular proof in your notebook for tomorrow. All right, so that's all I have for you today about the hypotenuse leg theorem. Please let me know if you have any questions. This is just one more tool you can use to prove that two triangles are in fact congruent.